Welcome back, everybody. Here are our next notes. These are atomic structure. I am hoping this is review for everyone. I have this awesome picture of an atom, and I'd like you to try and draw your own. You basically start with an oval, kind of tilted to one side, and then you cross and draw an oval tilted to another side, and then you draw an oval kind of sideways, and there are your electron orbits. In the middle, you'll have a jumble of pluses and neutrals. And on your orbits, you might put little negative signs. Here is a model of an atom. Add this drawing to your notes or find a drawing on Google Images and paste it in. You do need to know about the areas of the atom. In the middle of the atom is where we call the nucleus. That is where all of the mass of the atom is located. The area outside the nucleus is what we call the electron cloud, and that's where the electron clouds hang out and fly around really fast. We'll learn more about each of those particles coming up. I know you guys have seen this before. So a definition, atom, it's the smallest piece of matter that still retains the properties of the matter. That still retain the property of the matter. So the smallest piece of gold that is still gold is what we would call an atom. Subatomic particles are the pieces that make up the atom. So once we go inside the atom, the substances you're looking at no longer look like that element we were talking about. And I'm going to say gold because I've been on a gold thing today. So subatomic, sub meaning beneath or lower than, atomic, so smaller than the atom, particles that make up the atoms. There's three kinds of these particles. They're called protons, neutrons, and electrons. I know you've heard this before. Protons are in the nucleus. They have a positive charge. They have this mass. We call it 1 AMU. Every year my students like to call them AMUs. They're AMUs, okay? It's just a letter abbreviation. Neutrons are also located in the nucleus. They have no charge. They're neutral. They have a mass of 1 atomic mass unit. And an electron is found in the electron cloud, which is outside of the nucleus. They have a negative charge, and they are really flippin' small. 1 over 1,836 AMU. So an electron is about 2,000 times smaller than a proton. But even though the size is smaller, the size of the charge is equal and opposite of the proton. So where the proton is positive and it's got a certain strength, the electron is negative, so it's opposite and equal strength. AMU stands for atomic mass unit. In newer books, you'll just see it as U. And it's a unit of mass for subatomic particles. It's really little. It's 1.67 times 10 to the negative 27th. What does that look like if we were to write it out? It would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. That is how small yes, it says 27. I don't know why. 27 here, because this is 3 spaces. Oh, should I have one more 0 in there? Yes. There you go. That's how small of a kilogram a atomic mass unit is. What you need to know is that it's just really small. The other really cool thing is all protons, no matter what atom they come from, whether it comes from gold, hydrogen, uranium, tungsten, aluminum, does not matter what element the proton comes from, all protons are identical. All electrons are identical, and all neutrons are identical. Doesn't matter what atom you take them from. All right, the electron cloud, the definition is just the area surrounding the nucleus where we find the electrons, and the nucleus, dense. What does that mean? It's very heavy center of the atom. That's where all the mass is. That's where the protons and the neutrons hang out. All right, so the information that you are given on a periodic table will tell you the number of protons, neutrons, and electrons, but sometimes you have to do a little bit of math. So on your periodic table, you'll see the atomic number. The atomic number is the number of protons. It's called the identity of the element. So anytime you have a substance and the atoms of that substance have 5 protons, you're dealing with a substance that we would call boron. And the really cool thing is in a neutral atom, so if I use the word atom or if I say a boron atom, the number of protons and electrons are going to be equal. So when I see boron, symbol B on the periodic table, atomic number 5, I know it has 5 protons and 5 electrons. And then on the periodic table, they give you this average atomic mass. The average atomic mass is, not all borons are the same. Some have a little more mass, some have a little less mass, so we take an average. The average atomic mass is really your protons and your neutrons of borons added together. So on the periodic table, we can find out the number of protons, neutrons, and electrons just by knowing these 3 pieces of information. And I believe on almost every periodic table I've ever seen, you will see atomic number, symbol, and average atomic mass. All right, so how can we figure that out? The atomic number is the number of protons. This is the identity, did I spell that right? The identity of the element. When we use the word atom, it's considered neutral, so your positive charges have to be equal to your negative charges, so your P's are equal to your E's. And then you look at your average atomic mass here, and we round it to the nearest ones place. That is what we call the mass number. Mass number is quite simply the number of protons added to the number of neutrons. And on the periodic table, I told you it's an average, so you want to get what it is normally, and we round it to the ones place. I'm going to make that bigger. All right, so we're going to practice a few of these, and you guys can follow along and see how well you do. All right, so we've got boron. How many protons in boron? It's atomic number 5. And yeah, if you guys could by hands put them up there and show me how many protons does boron have. All right, so the atomic number of boron is 5, so that tells me the number of protons is 5. And it's a neutral atom, so what do I know about the number of electrons? The positives and the negatives have to be equal, so the number of electrons are also 5. Now, how do we find the number of neutrons? I take this number, and I have to round it to the ones place. I know we struggled with rounding before. 10.8, does it stay at 10, or does it round up to 11? 11. All righty. So we have 11. This is our rounded number. We're going to subtract the protons, and that gives us the neutrons. All righty. So why don't you guys go ahead and pause and try this next one, potassium. No, really, I mean it. Pause and try potassium. I know you think I was kidding. Pause and try potassium. I'm recording this in front of my class right now, so I want you guys to all try potassium on your own. All the information you need is right here. Oh, and announcements. Seriously.
Spring baseball who are not currently in a winter sport should attend an informational meeting on Tuesday, November 13th in the Old Plain Cafeteria at 3:25.
How many of you did okay on potassium? A lot of students will say, how come the number of neutrons isn't the same? It doesn't have to be, and it doesn't matter how many neutrons you have, because it doesn't upset the balance of the positives and the negatives in the atom. And the neutrons are really important because they're kind of the spacers between the protons. And the protons, they don't really like to touch. You know, sometimes you have people in class, they don't like to sit by each other, so I might put a buffer in between people. All right, neutrons kind of like that. They're a buffer between your protons. All right, for krypton here, do you notice a pattern with the protons and the electrons? Yeah, they're the same. All right, neutrons here. 84 minus 36. 14, 6, 8, 7 minus 3, 8. Alrighty. I should be able to do the math in my head, and I don't. I always make silly errors when I do the math in my head. Nope. 7. Are we okay with this? That iodine has so many more neutrons than protons? The answer is yeah, it's okay. They're like buffers. It's what? 74? Oh, well, heck. Geez, Louise. Thank you for correcting me, and this is why I should use a calculator. All right. Atomic structure. So to summarize it, basically, these are the protons, neutrons, and electrons. These are the building blocks that make up all atoms. And by looking at the periodic table, I can tell the numbers of protons, neutrons, and electrons in an atom. And this is important because it can tell you a lot about the chemical properties of an atom. All right, talk to you guys later. Bye.